welcome back to this course, DBMS course. And now we are in chapter 5, part 1. So there will be two sections about chapter 5. The first sections will talk about introductions to normalizations, but in these sections we just talk about the basic concept, why we do the normalizations in database, and then we will look into some guidelines for relation schemas, and then the functional dependencies includes the definitions, and then how does it look like, and then some types of the functional dependencies, and then right after that we will see some anomalies in relational database and some of the various anomalies. Okay, so let's start with the introductions to normalization. So basically, it's a process to decide which attribute should be grouped in a relation. Okay, let's check. What is normalization? So in this sections, in this part, we will look into two definitions. The first one is related to normalizations, and then the second one is the functional dependency. Okay, so now first we go into the definitions of normalization. So normalization is a process to organize data in a database. It's to reduce the redundancy or to the repeated data and avoid some potential problems like incorrect data, something like that. So the goal of the normalization is to design a database in such a way that each piece of information is stored in the most efficient and logical place. This will help to make the database easier to maintain and faster to query and less prone to error. For examples, if you have a database with customers' orders and you store each order along with the customer's address, if the customer places multiple orders, you might store the address again and again, right? And it's leading to redundant data. This will cause problems when the address changes because you will have to update it every place where it's stored. So we have normalization here, which is to reduce this kind of redundancy of data by breaking down the large tables into smaller and related ones. And you will store the customer's address in a separate table and then link it to their orders. So the address only appears once, and this makes updates easier and ensures that you don't have ended up with the extra and incorrect data, something like that. Okay, so that was the normalization. Now we move to the second definition. It's the functional dependency. So functional dependency, it's a constraints between the attributes. It's more like a concept used to describe a relationship between two attributes or set of attributes in a database. So it's like a rules that tells you how one attribute depends on another. So let's say you have a table of students and each student has a student ID and a student name. We can say that student ID determines the student names, right? And this means that for each student ID, there is one and only one student name. So the relationship between these two can be expressed like student ID related to student name, something like that. This tells us that knowing the student ID is enough to uniquely determine the student name. Okay, something like that. So, the purpose of the functional dependency is to help in organizing data efficiently because they tell you how to different pieces of data are related to each other. This knowledge will help to guide you when you are normalizing a database. So these two, normalization and functional dependency, is connected to each other. If you know the functional dependency in your database, you can break down your tables in a way that eliminates redundancy and avoids update anomalies. Yeah, it's kind of problems when you insert or you delete or modifying a data. And then makes the structure of the database more logical. So to sum up, the normalization is the process of organizing data in a database to reduce the redundancy and avoid errors, ensuring the data is stored in the most logical way. Meanwhile, for the functional dependency is describing relationship between the attributes and help in the organizing data more efficiently by identifying how one attribute depends on another. Okay, so when we use these two together, the normalization and functional dependency, it will ensure that the database is well structured, is easy to maintain, and avoid unnecessary complications. So, the purpose of the database design is to arrange data without repetition. By organizing data carefully, the database design minimizes data repetition. This will reduce the storage cost and ensures that when data is updated in one place, it doesn't need to be updated in multiple places. Okay. Another purpose of database design is generate a structured relationship. A database design establish structured relationship between different tables using keys, right? Like a primary key and foreign key, something like that. And this relationship makes sure that the database reflects real world connections and that each table can be linked logically to others. So what is the benefits of this normalization? The benefits of normalization is include the reduced redundant data because the normalizations will break down the tables into smaller ones that each focus on a specific entity, which reduces or eliminates repeated data across the database. And of course, ensures the data consistency. With reduced redundancy, the normalizations will ensure that each piece of data is stored in only one place. So when it's updated, there is no need to worry about inconsistencies. For example, if a customer's address changes, you only need to update it in one table rather than several tables. Okay. So overall, the normalizations will help to create a well-organized, efficient database that's easy to maintain, reliable, and optimized for data integrity. So normalization is a process in database design with the goal of organizing data efficiently by structuring tables to reduce the redundancy and prevent anomalies. Okay, so again, in normalization, you decide how to group attributes, yeah, in columns, in tables, in relations based on their logical connections. This means that carefully selecting which attributes should be grouped together in the same table to ensure the data is organized logically. If a table has problems like redundancy or anomalies, for example, insert, delete, or update anomalies, the normalizations will involve decompose the table or breaking it down into smaller tables. And these small tables are organized so that each one holds a specific set of related data and they connect to each other through keys such as primary and foreign keys, something like that. So the outcome of the normalization is a set of well organized tables that avoid the redundancy. Yeah, so each piece of information is stored only once, which reduce the unnecessary duplications and also prevent anomalies with a clear structure. The database avoids update, insert, and delete anomalies, making it easier to maintain consistency. So again, the normalization is needed in the database because a database is transformed into a structured, efficient design that minimizes the redundancy and ensures the data integrity. All right, we move to the next one. It's about the informal design guidelines for the relational schemas. Okay. Okay, so the first one is the meaning or semantics of relation attributes. It means that here in this process, each attribute in a database relation should have a clear, real world meaning that reflects the data it represents. This clarity ensures that all values within the tuple or rows are logically connected and relevant to one another. So we have some guidelines for the first. Uh, so first one, when deciding a relation schema or the table structure, you need to make sure it's easy to explain to others. And its schema should represent a single coherent entity or relationship type rather than combining the unrelated concepts. Why this matters? Of course, this matters because we need to clarity of the database. If each attribute has a well-defined meaning, it will help the users to understand the purpose of the data and prevents confusion. And we also need what is called data integrity. So it's ensured that logical consistency within the tuples will minimize the risk of errors and anomalies. And a simpler maintenance. A clear single purpose schema is easier to maintain, easier to carry and extend in the future. So, as the examples, listen to me. As the examples, if you have a database for a library, we have a book relation. Okay, so the book relation should contain the attributes that are clearly related to books, such as book's ID, and then the title, and the author, and the publisher, right? And it should not, however, include unrelated information like member ID, borrow date, instead of borrowing detail should be in the spirit borrowing relation that connects members to books, something like that. So this keep each schema focus on a specific aspect of a data, something like that. And the next one, uh, it's about redundant information and update anomalies. So redundant information, that means storing the same data multiple times in a database. Imagine you have a table with customer information and you store the customer's address in several different places. If the address changes, you would need to update it everywhere, which can be error and inefficient. So, to avoid this, we try to store each piece of information just once in the right place and then link it to other data when it's needed. And this helps in saving space and reduce the chances of the mistakes. Okay. And then there's some types of anomalies. Sorry, the types of update anomalies. So an update anomalies is a problem that happens when you try to insert, to delete, or to modify a data. And it doesn't work properly because of the redundant data. There are three types of the update anomalies. Yeah, the first one is insert anomalies. We will, of course, take it, but discuss it one by one. So, insert anomaly. This happens when you cannot add a new information to the database without adding unnecessary or incomplete data. So, for examples, if you try to add a new customer but don't have yet an order for them, so you might be forced to leave some fields blank or you need to store duplicate information, right? So it's a insert anomaly. And then the delete anomaly. This happens when you try to delete some information, but it accidentally causes the loss of other important data. For examples, if you delete a customer's record, but their order information is also lost, even though the orders should be still kept in the database. And the next anomalies is the modify anomalies. This happens when you change information in one place, but you forget to update it in another places where the same data is stored. This is also a problem. So this can lead to inconsistencies, like having different addresses for the same customer in different places. So the guideline for avoiding the update anomaly, you need to design the database carefully. The goal is to organize the data in a way that minimizes redundancy and ensures that updates happen smoothly. So, one common approach to achieve this normalization where you break down the large tables into smaller, more manageable ones. And by doing this, you ensure that each piece of information is stored in only one place. Okay, so there is no redundancy. And if there is an updates will be easier and less likely to cause errors or anomalies. All right, so next is the avoiding null values in the tuples. Yeah, this is also important. So in a database, a tuple is just a row in a table, and each attribute is a column that in a row. Null represents missing or unknown value or unknown data in a database. So when you designed a database, one common problem is that if you group too many attributes or columns in one table, you might end up with a lot of null values. Okay, so the issue is with nulls, when you put many attributes in a single table, you might have some rows where a certain attributes don't have a value. It means null. They are null. So this will create a problem. Yeah. First is wasting your space. Storing a null values still takes up some storage space, even though it doesn't actually contain any useful data. The more nulls you have, the more space is wasted. So try to avoid a null value. And the ambiguity. So a null can mean different things. Yeah. It can be a noun. The unknown is information is just missing that we don't know the value should be. It's a noun. And in applicable, the attribute doesn't apply to the role. Yeah, for example, a middle name for someone who doesn't have one. Okay, like for me, I don't have a middle name except for Chinese name. I have a middle name. And then missing. Okay, missing. So the value should be there, but it's not just available at the moment, something like that. And this will create what is called a confusion because it's not always clear why a value is new. Is it missing? Is it a noun or just not applicable? That can lead to mistakes when using our data. Okay. It also complicates operations. When you perform operations like count or sum, the null values can mess up the result. For example, if you try to sum columns with the prices and some values are null, the calculation might fail or return incorrect results unless you specifically handle the null value, something like that. Okay, So the guidelines to avoid the frequent nulls is um, try to design your tables so that the null values are only used for exceptional cases, like situations where it's absolutely necessary to represent the missing or unknown data. Okay, so for example, instead of having a columns for a customer's middle name, which might be null for many people, consider whether it's better to store this information in a spare table only when it's needed. Okay, this way you can reduce the chance of many nulls cluttering up your tables. So in short, try to limit the use of nulls value to only when absolutely necessary. And then try to design your tables so that each attribute is relevant to most rows, or you can use separate tables for optional information. And this will make the database more efficient. It's easier to understand and simpler to work with. Okay. And the next is preventing spurious tuples. What does it mean? What are the spurious tuples? Okay, so a tuple is just a row in a database table, and spurious tuples refer to unwanted or incorrect rows that can appear as the result of an incorrect joined operation between two tables. Okay. Okay, so to understand this part better, let's imagine that you have two tables, one for students and one for courses. Okay, I wish I can write it here, but now I cannot. Okay, so the students table is each students and their details. Try to write it down here. I have a students table over here. Okay, I don't have my pen, so it's very difficult. Okay, student table. So it's a student table is each student and their details, and then I have another table is a course. Okay, okay, it's course and students table. So this course table will list all courses and who's enrolled in this course. Okay, so let's say you want to join these two tables to see which student is in which course. Okay, so you might accidentally join them incorrectly, leading to spurious data. Okay, spurious data, like the same student showing up multiple times for a course, or student being linked to the wrong courses, right? This is the what is called spurious data. So this is unwanted data. Okay, when you join these two tables, the database tries to match the rows based on the certain attributes. If the join is done incorrectly, for example, joining tables based on non-unique columns or incorrect relationship, it can produce an extra or irrelevant rows. And these are the spurious tuples. Okay. So, for instance, if you join the students and courses tables based on an incorrect or a non-specific attributes like student name instead of student ID, you could get rows that don't make sense, such as student enrolled in two courses multiple times if they, for example, have the same name. Like there are Robert from class A and Robert from class B. So that will be a correct combination of the students and the courses. So there is what is called guideline 4. This is to helps to avoid, to prevent what is spurious tuples. So the guideline is you need to design your tables and schema so that the joins are always done using primary key and the foreign key attributes. So the primary key is the unique identifier, as we know, for each row in a table. So for examples, in the students table, a student ID could be the primary key of the table. And then the foreign key is the column in one table that will links to the primary key of another table. For examples, in the courses, okay? In the courses table, a student ID could be a foreign key that links to the student table. Okay, so by using the primary keys and foreign keys for your joins, we can make sure that each rows in the result is linked correctly, uh, no extra rows or wrong combination. And then it's to prevent duplication or mixing of data that leads to spurious tuples. Okay, so to conclude, the spurious tuples happened when incorrect joins lead to extra or incorrect data. So to avoid this, always join tables using primary keys and foreign keys, because these keys ensures that the relationship between the tables are clear and correct. These guidelines will help to keep your database queries accurate, efficient, and meaningful. Okay, so in practice, if your tables are designed well and have proper keys, the database can ensure that joins result in clean and correct data without unwanted rows. All right. So let's move on to the next. Is the part 3 is the functional dependency. So in this part, we will try to understand more the functional dependency in the database. This is very important because if you master this part, then you won't have any problems when you are doing the normalization. Okay, so let's start it. Okay, so let's start with the definitions of functional dependency. So functional dependency, or FD, describes a relationship between the attributes in a database where one attribute determines another. In relation of R, if attribute of Y is functionally dependent on X, it's written as X, Y, arrows Y, then it means that a specific value of X uniquely determines a single value of Y. So we can say that X is the determinant. Okay. I believe that you are still confused about this. Yeah. So let's check the tables over here, the employee tables. In the employee table, we have employee ID, which is uniquely determines the employee name and salary, of course. We can express this dependency as employee ID to employee name, and here the employee ID is determinant, as knowing as the employee's ID is enough to determine their name. So the functional dependency here is helping to maintain the data integrity, and it's essentials in database normalizations to eliminate redundancy and anomalies. All right. To create a functional dependency chart for a relation, we need to follow the 4 steps, okay, and organize them. Okay. Um, First one is to identify the primary key attributes. We need to determine the attributes or the combinations of the attributes that uniquely identify each record in the relation. And these are your primary key attributes. Okay. So, and after that, we draw a rectangle for primary key attributes. Draw a rectangle and then write all identified primary key attributes inside of it. And this rectangle visually separates the primary key from the other attributes. And the next step is place non-prime key attributes outside of the rectangle. Okay, so non-prime key attributes, those that are not part of the primary key, should be listed outside of the rectangles to show that they don't form part of the unique identifier. And the last step is to indicate functional dependency with arrows. Yeah. So we need to use arrows like this to represent the functional dependency. Draw the arrows from the determining attributes inside or outside the rectangles to the dependent attributes, just like this. And the directions of the arrow, it signifies the dependency. Yeah, for example, uh, employee ID to name and employee ID to salary. And these methods will help to visually organize the dependencies, making it easier to understand the relationship between the attributes and to identify any redundancy or anomalies in the relation. Okay, next one. We're still in the chart of functional dependency. So we have an examples uh, of a professor. So it's the relation of professor. We have professor code and a department, head and time. Okay, so professor can work more than one department, and the time here, it means that how long he spent in each department. Okay, and each department only have one head. Okay, and then to draw the dependency for the given relation, as you can see in this picture. Okay, so it's the professor code. Okay, so it depends on the department, and we have to draw this rectangular. So this time is dependent on the professor code and department. Okay, so that's why the arrow is connected to the rectangle. It's not connected to one of its attributes. Okay, because the time, it depends on the professor, how long he spent, how long the time spent for each professors to work in each department. Okay, so the time is depends on these two, so that the arrow is from the rectangle. Okay, instead of each one of the attributes. And then head, the head, as you can see that each department has only one head, so the arrows is drawn from the attribute department to head because it's directly dependent. Okay, okay, so far so good. Now let's move on to the next one. It's the types of functional dependency. So there are four types of functional dependency. The first one is partial dependency and fully functional dependency. The second is transitive dependency and non-transitive dependency. The third, the single valued dependency and multi-valued dependency. And the last type is trivial dependency and non-trivial dependency. Okay, let's talk about this one by one. So partial dependency, it happens when a non-prime attribute, or we can say an attribute that's not part of the primary key, is dependent on only part of the composite primary key rather than the whole key. Okay, so a composite primary key here means that the primary key is made up for more than one attribute. So the partial dependency can only occur if there is a composite key. Okay, so that was the partial dependency. Now, the fully functional dependency. So the fully functional dependency, this occurs when the non-prime attributes depends on the entire composite of primary key. So in other words, if you need both parts of the primary key to determine the attribute's value, it's a fully functional dependency. Let's take a look at the examples, okay? Uh, so this happens, you remember that partial dependency happens when a non-prime attribute, or we can say an attribute that's not part of the primary key, is dependent on only part of the composite primary key rather than the whole key. So a composite primary key here means that the primary key is made up more than one attribute, and partial dependency can only occur if there's a composite key. So we can see in this picture in a student relation with a composite of primary key, roll number, and game. So suppose we have non-prime attributes of name and fee. Okay, so the fee is represents the fee of the particular game. Okay, and name is only depends on the roll number. So you can find a student's name by just knowing their roll numbers, and fee, it depends only the game. So the fee is based on the game itself. Since a name and fee don't depend on the entire composite key, yeah, the entire composite key is the roll numbers in game, so they are partially dependent. Okay. Meanwhile, for the fully functional dependency, this occurs when a non-prime attribute depends on the entire composite of primary key. So in other words, if you need both parts of the primary key to determine the attribute's value, it's a fully functional dependency. So in examples, for example, for the fully functional dependency, um, in the same student relation with roll numbers and game as the primary key, the grade depends on both roll numbers and game, because you need to know both of the students' roll number and the game to determine their grade in that specific game, something like that. And since grade depends on the entire composite key, so it has the fully functional dependency. Okay, so in summary, the partial dependency means that non-prime attributes depend only on part of the composite key. Meanwhile, the fully functional dependency means that non-prime attributes depends on the entire composite key. Okay. Now the second type is transitive dependency and non-transitive dependency. So a transitive dependency will occur when one attribute indirectly determines another attribute through a third attribute. Meanwhile, a non-transitive dependency occurs when an attribute is directly dependent on a key attribute and not through another non-key attribute. Okay, let's move on to the examples for your better understanding. Alright, so let's understand the transitive and non-transitive dependencies with the examples given in the image. So you remember that transitive dependency occurs when one attribute indirectly determines another attribute through a third attribute, right? So here in these examples, we have roll numbers, we have semesters, we have name, we have hostels, right? So roll numbers is a prime attribute, so it's a key attribute. Meanwhile, for the semesters and hostels are the non-prime attributes, so it's not a key attribute. Okay, so in a transitive dependency, the hostel is transitively dependent on roll number through a semester. This means that roll numbers determine semesters and semesters in turns determines hotels. For instance, if we know the roll numbers, we can find out the semesters the students is in, and if we know semesters, we can determine which hostels the students is assigned to. Okay, so the next type is non-transitive dependency. So if you remember, the non-transitive dependency occurs when an attribute is directly dependent on a key attribute and not through another non-key attribute. So for examples, we have a roll's number and name here, okay? So name is directly dependent on roll numbers. Knowing the roll numbers directly will tell us the student's name without needing any intermediary attributes. So this diagram shows the relationship between the roll's number, the name, semester, and hostels, where the roll number is the X directly determines the name, and the roll numbers also determines the semester, but semesters in turn determines the hostel, okay, the Z. It's showing the transitive dependency. So in summary, the transitive dependency when one attribute indirectly determines another attribute through a third attribute. Yeah, for example, roll numbers to semester, semester to hostels. Meanwhile, for the non-transitive dependency, when an attribute is directly dependent on a key attribute and not through any other attribute. Yeah, for examples, roles numbers to name. Okay. So the next type of the functional dependency is the single valued dependency and multi-valued dependency. So the so single value, okay? The single value dependency occurs when one attribute determines exactly one value of another attribute. So that's we call it single because one to one. Okay, one attribute determines exactly one value of another attribute. Meanwhile, for the multi-valued dependency, it occurs when one attribute in a table determines multiple values of another attribute independently of other attributes. Okay, so let's check for the examples. So as you can remember that multi-value dependency occurs when one attribute in a table determines the multiple values of another attribute independently of another attribute. Okay, so for examples, in teacher and class, okay, teacher and class, and each teacher can handle multiple classes, okay, each teacher can handle multiple classes. For example, in Sam, teacher Sam handles both computers and electronic classes, okay. So this creates a multi-valued, okay, multi-valued dependency because the value of the teacher attribute, like Sam, okay, can determine multi-values of the class attribute independently of the other attributes. So we can see these two arrows, yeah, connected teacher with the class, okay. The next dependency is between class and days. So each class can be held on multiple days, 1 to 6, right? And this is another multi-value dependency because the value of class, the value of class attributes can determine multiple values of the days. Yeah, for examples, computer class can be held on day 1 and day 6. Meanwhile, for the class of mechanical can be held days 5 and days 2, something like that. Okay. And let's talk about the single value dependency. So the single value dependency occurs when one attribute determines exactly one value of another attribute. So we're talking about ID and teacher over here. Each ID uniquely identifies a teacher, right? So for examples here, 1Z corresponds to Sam. Okay, 1Z corresponds to Sam. 2Z corresponds to John. And this is single value dependency because each ID determines one, okay, and only one teacher. And as you can see here that for the dependency diagrams, yeah, the arrows indicate the directions of the dependency. The teacher determines class. It's a multi-valued dependency, so we have two arrows over here. And then class determines days. It's also a multi-value dependency, so we can see here there are two arrows, and ID with the teacher is a single valued dependency, so we only see one arrow over here. All right, so to sum up, the multi-value dependency is one attribute determines multiple values of another attribute independently of other attributes. Yeah, teacher to class. A teacher can teach multiple classes, for examples. And for single value dependency, when one attribute determines exactly one value of another attribute. Yeah. For example, ID of the teacher is uniquely identifies a teacher. Okay. So the last type of the dependency is the trivial dependency and non-trivial dependency. Okay, so the trivial dependency is a dependency where x towards y is called trivial if y is a subset of x. So this means that the dependent attributes of y is already contained within the subset of attributes x. It's the trivial dependencies. And the trivial dependencies are not meaningful because they don't provide new information, to be honest. For examples, okay, for examples, if we have a set of attributes, yeah, it's A and B. So the dependency of A and B, if it's part of the A, is trivial because A is already part of A and B. Yeah, just okay. So it's not nothing new. It's not new information. Okay, and then a non-trivial dependency. So it's a dependency of x and y when if y is not a subset of x. So it's a non-trivial dependency. So in other words, we can say that y contains attributes that is not part of x. And this time, the non-trivial dependency are meaningful because they show the actual relationship between the different attributes. Okay, let's take the examples for your better understanding. Okay, so you remember that trivial dependency is when an attribute or a set of attributes is functionally dependent on a larger set that includes it. In other words, if you already have an attribute in a set, it's trivial dependent on the whole set. Okay. In the supplier product relation, okay, this is S, it's for the supplier ID, and then P is the product ID. Okay. The dependency of S and P, S and P is a trivial dependency as the S is a subset of S and P. Because S, the supplier, is already in a larger set of S and P. So it's trivially dependent. Okay, and then let's talk about the other dependency, which is called non-trivial dependency. So non-trivial dependency occurs when an attribute or set of attributes is dependent on another set that does not include it as a subset. So this kind of dependency is meaningful because it reflects a true relationship between the attributes that are not trivially related. Okay, for examples, in the relations of R, it's over here. An example of a non-trivial dependency is 0 to P, meaning the value of P, where the value of P depends on the value of O, okay? But P is not a subset of O. This makes it meaningful or non-trivial dependency because knowing O determines P in this table. Okay, so in the relation of R, we have a columns O, P, and Q. Okay, by observing this data, we can find the non-trivial functional dependency. Yeah, for examples, the O to P holds because each value of O corresponds to only one value of P in the table. Yeah. However, O to Q does not hold because the same value of O like 2 has a multiple values for Q. Yeah, both 7 and 5. So there's no unique dependency from O to Q. So the non-trivial function dependency help to describe meaningful relationship in a data, while trivial dependency don't give us any additional useful information. All right, let's move on to the next sections, which is about the anomalies in relational database. Okay. So what is anomalies? Anomalies are the undesirable outcomes that can happen when you modify data in a database. Okay, so anomalies are the undesirable outcomes that can happen when you modify data in a database. So there are various anomalies. Okay, the first is called insert anomalies. It happens when you are unable to add certain information to a database without also adding another or related information. Okay, for examples, suppose that you have an employee table that stores information about employees and their departments. Each employee has a unique employee ID, in this case, a primary key, which cannot be empty or null. Now, let's imagine you want to add a new department of finance, but currently there are no employees in that department. So, with that current uh, condition, you cannot add the finance department on its own because there's no employee to associate with it. And since the employee ID is required and cannot be new, this means that you cannot enter the finance until there's an employee assigned to it. This limitation is an insert anomaly because you are unable to add finance as a department without the dependent data, for example, as an employee in this case. And this type of anomaly can restrict flexibility in managing your data, especially if you want to keep track of departments independently from the employees. And the next anomalies is delete anomalies. So delete anomalies happens when removing a piece of data also cause you to lose the other important information you didn't mean to delete. For examples, let's say you have an employee table where each employee's records includes their department. Now suppose you have an employee named Deepak in this case, who is in the only person in the sales department. Okay. If you delete Deepak's records, maybe because he left the company, you will also lose the information that sales department exists, since there's no longer anyone listed under sales. Okay, so this can be a problem if you wanted to keep track of all departments, even if they currently have no employees. The delete of Deepak's records unintentionally removes the sales department information, which could lead to a data loss that you didn't intend to it. Okay, so that was the delete anomalies. And the next anomalies is the update anomalies. An update anomalies happens when you need to update data in multiple places, and missing even one update that will cause mistakes in your data. Okay, imagine if you have an employee table where each employee has a department number, okay, department number, to show which department they work in. Let's say there are 5 employees in the accounts department, all with department number of 201. Now if the department number for accounts changes to 301, you would have to go through the employee tables and update the department numbers to 301 for every single employee in accounts. If you miss even one employee, the table will have inconsistent information. So some employees in accounts will still show the department number of 201, while the others show 301. Okay, and this inconsistency can lead to errors because the same department would appear with two different numbers. And the update anomaly makes it easy to have a bad data in your database if changes are not made everywhere they are needed. Okay, now let's check your understanding. Okay, in this table, we have some columns which describes the details about the student, like their name, their birthday, age, and then address, and department ID, and also the student ID, of course. And this table is not normalized, and there is definitely a chance of anomalies present in the table. Okay, so the 3 possible anomalies, let's see. When we update some rows in the tables and if it leads to inconsistency of the table, then this anomaly will occur. This type of anomaly is known as update anomaly, right? And in this table, if we want to update the address of count, then we have to update all the rows where count is present. Okay, if during the update we miss any single row, then there will be two address of count. Okay, which will lead to inconsistent and wrong database. And the second possible anomaly, okay, if there is a new row inserted in the table and it creates the inconsistency in the table, that is called the insert anomaly. For example, if in the table we create a new student and it is not located to any department, then we cannot insert it in the table. So it will create what is called an insert anomaly. The third possible anomaly is delete anomaly. If we delete some rows from the table and if any other information or data which is required is also deleted from the database, this is called delete anomaly in the database. For example, in the table, if you want to delete the department of 006, then the details of Diana will also be deleted because the Diana's details are dependent on the row of 006. So there will be a delete anomalies in this table. Okay, so how to solve this problem? Okay, so to remove this type of anomalies, we will normalize the table or split the table or join the table. There can be various normalized form of table like 1NF, 2NF, 3NF, BCNF, and etc. We will discuss it in the next sections, in the next part of this chapter, okay? Which we can apply the different normalization schemes according to the current form of the table. All right, let's take another table. So in the table, we have listed students with their name, their ID, their branch, and their respected club. So in the table, if Eva changes her branch from computer science to science electronic, sorry, computer science to electronics, then we will have to update all of the rows. Okay, Eva have two rows over here. If we miss any rows, then the Eva will have more than one branch. Am I right? And this will create the update anomaly in the table. And then if we add a new row for a student, for example, I add here Thomas, who is not part of any club. He's not joining any club in the school. We cannot insert the row into the table as we cannot insert new for the column of students club. So this is called insert anomaly. And then if we remove the photography club from the college, then we will have to delete its row from the table. but it will also delete the table of their law and his details. So this is called delete anomaly, and of course it will make the database inconsistent again. All right, if you have any questions, just send me email. That's all of the chapter 5 part 1. We will meet again in chapter 5 part 2. Okay, have a nice day. Goodbye.